The double-slit experiment, a cornerstone of quantum physics, brilliantly reveals the deeply strange nature of reality at its most fundamental level. First, picture firing tiny marbles, one by one, at a barrier with two narrow slits. Behind this barrier, a screen displays where they land. As you'd expect, two distinct bands appear, corresponding to the marbles passing through one slit or the other. Straightforward. Now, consider waves, like water waves, encountering those same two slits. The waves emerging from each slit spread out and interfere with each other. Where wave crests meet, they amplify. Where a crest meets a trough, they cancel. The result on the screen is an interference pattern, a series of alternating high and low intensity bands. This is classic wave behavior. Here's where the quantum world truly bends our minds. Let's fire particles like electrons, one at a time, so they can't interact with each other. Astonishingly, even when fired individually, these electrons gradually build up that same wave-like interference pattern on the detector screen. It's as if each single electron somehow explores both paths simultaneously as a wave, interferes with itself, and then registers its arrival as a single point. But the enigma deepens. If scientists decide to peek and place a detector by the slits to determine which slit each electron actually passes through, the quantum magic shifts. The very moment we gain knowledge of the electron's path, the interference pattern vanishes completely. The electrons then behave just like our simple marbles, forming only two distinct bands on the screen. The act of observation, of measurement, fundamentally alters the outcome. It's as if the electron knows it's being watched and chooses to behave as a definite particle rather than a spread-out wave. The double-slit experiment unveils the core mystery of wave-particle duality, the extraordinary ability of quantum objects to exhibit both wave-like and particle-like properties, depending entirely on how, or even if, they are measured. It powerfully demonstrates that in the quantum realm, the observer is not merely a passive spectator, but an intrinsic part of the system, challenging our deepest intuitions about reality. Imagine trying to photograph a ghost, something that, by its very nature, devours light. This was the colossal challenge facing astronomers wanting to glimpse Sagittarius A star, the supermassive black hole, a 4 million solar mass behemoth, lurking silently at the fiery heart of our Milky Way galaxy, 27,000 light-years away. To see it would require a telescope with vision so sharp, it's like trying to spot a single grain of sand on the beaches of Los Angeles, all the way from New York City. No single lens on Earth could ever achieve this. So humanity built a virtual eye the size of our planet, the Event Horizon Telescope, or EHT. This isn't one instrument, but a symphony of radio telescopes scattered across the globe, from volcanic peaks in Hawaii to the desolate plains of Chile, from Spanish mountains to the frozen Antarctic plateau. Using a breathtaking technique called very long baseline interferometry, these distant eyes are precisely synchronized by atomic clocks, observing Sagittarius A star in unison. They become facets of one colossal planet-spanning lens. What they capture isn't a snapshot of the black hole itself that remains forever cloaked. Instead, they trace the dance of light and superheated gas caught in its inescapable gravitational grip. We see the black hole's shadow, an abyss of darkness where light makes its final plunge, dramatically silhouetted against the swirling, incandescent glow of matter accelerated to near light speed, a final scream before oblivion. Einstein's theories predicted this gravitational light bending perfectly. Petabytes of raw data, too vast for the internet, are recorded on hard drives and physically flown to supercomputing centers. There, for months, intricate algorithms, as ingenious as the telescopes themselves, painstakingly weave together these faint cosmic whispers, correcting for Earth's turbulent atmosphere and instrumental quirks, to reconstruct one astonishing image. What emerged was not just a picture, but a profound revelation, direct visual proof of the monstrous yet invisible engine at our galaxy's core. a triumph of global collaboration, relentless ingenuity, and our unyielding quest to see the unseen.